Hello students, myself Dr. Ahmed. Welcome to the third session of Bridge Course for Engineering Mathematics. Students, in the last session we have learned what is the meaning of limit, what is the meaning of left hand limit, what is the meaning of right hand limit, and when does the limit exist, and how to evaluate the limit. We have for that we have seen 4 different methods. Students, in today's lecture we will see what is the meaning of derivative and how to evaluate the derivative and what will be the geometrical interpretation of derivative. So let us put the title derivative. Okay students, let us see the derivative of a function at a point. So I'll write the definition. Derivative at a point. Suppose students, I am having a function f of x. I am having a function f of x which is defined on the open interval a comma b. I am having a function f of x which is defined on the open interval a comma b, and let c belongs to open interval a comma b, means c is a number in between a and b. Then f of x is said to be differentiable. F of x is said to be differentiable at x equals to c if and only if this limit exists. The limit that I am going to write, limit x goes to c, f of x minus f of c by x minus c, if this limit exists, right? So what is the definition of derivative at a point? Suppose I am having a function f of x. This function is said to be, suppose this function is defined on the open interval a comma b, and I am considering a point c which is in between a and b. Then this function is said to be differentiable. Then the function f of x is said to be differentiable at the point x equals to c. Here I am considering the derivative at a point. So function f of x is said to be differentiable at the point x equals to c if and only if, means if this condition is true, then the function is said to be differentiable. If the function, and in vice versa, if the function f of x is differentiable, then this limit will exist, right? So f of x is said to be differentiable at the point x equals to c if and only if this limit x goes to c, f of x minus f of c by x minus c exists, right? Now I'll make a note here. Throughout this discussion I am going to consider f of x is differentiable. I am considering that f of x is differentiable throughout our discussion. What is the meaning? If f of x is differentiable, then according to this definition, this limit will always exist, right? According to the definition of differentiable at a point x equals to c is nothing but this limit will always exist. And in the previous session students, we have learned when does this limit exist. Any limit said to be exist if left hand limit and right hand limit are equal. The same thing here, because I am considering that f of x is differentiable, so this implies what will happen? Left hand limit of this, that is c minus f of x minus f of c by x minus c. This left hand limit and right hand limit will be equal, that is limit x goes to c plus f of x minus f of c by x minus c, right? So since I am considering that f of x is differentiable, so left hand limit and right hand limit will be equal, because differentiable means this limit should exist. This limit should exist means left hand limit and right hand limit should be equal. Then further this can be written as, from the last session I am writing this, limit h goes to 0. This can be written as f of c minus h minus f of c by, here in place of x what I have to write? C minus h. So c minus h minus c. C minus h minus c is nothing but h. So further limit right hand limit, how can I write? Limit h goes to 0. in left hand limit we have to write f of c minus h, and in right hand limit we have to write f of c plus h minus f of c by, again here c plus h minus c, so I'll get h here, right? Here we'll get minus, here we'll get minus, because when I put in place of x, when I put c minus h minus c is nothing but c gets cancelled, minus h will remain, right? So these two limits will be equal. This limit exists means left hand limit will be equal to right hand limit, which is nothing but this limit is equal to this limit. So if this limit exists, if I write only this one, if only this limit exists, then I can say that the given function is differentiable. Or if the function f of x is differentiable at the point x equals to c, then this limit will always exist, right? So we'll see few problems. We'll see few problems in which we will be using the definition, this one. So before that, if this is happening, the function f of x is said to be differentiable, and also this limit is called as the derivative of f of x. First of all, the derivative of f of x is denoted by f dash of c, because we are finding the derivative at the point c, or d by dx of f of c. I am finding the derivative of f with respect to x at the point c, right? These are the notations for derivative, and the value of this the value of this derivative will be equal to this limit, right? Or I can write this limit also, because this limit exists means left hand limit, right hand limit are equal, means these are equal, means this is existing means this is existing, and this is existing means the function is differentiable. So that's why I can write here as limit h goes to 0 f of c plus h minus f of c by h, right? So this will be the definition for derivative, right? Now we'll see problems. We'll consider first problem. Hope students it is clear to you. Once again I'll explain. Derivative at a point, how do we define? Suppose I am having a function f of x which is defined on the open interval a comma b, and I am considering c a point which lies in between a and b, right? Then the function f of x is said to be differentiable at the point x equals to c if and only if this limit exists. What is this limit? Limit x goes to c, f of x minus f of c by x minus c. If this limit exists, then we say that f of x is differentiable at the point x equals to c, right? So I am making a note here that I am considering throughout our discussion, we are considering that throughout this topic derivative, we will consider f of x to be differentiable. If f of x is differentiable, according to this definition, this limit should exist. If this limit exists, according to the second session, left hand limit and right hand limits should be equal, that I am writing here. These limits can be written in the form of h. By using h, we can write these two limits in this form, right? Now, since I said that f of x is differentiable, I need a notation for representing this limit. I need a notation, whatever the limit I am going to get, that is denoted by the derivative of f at the point c, or df by dx at the point c, and this value of this derivative is given by this limit, right? Students, now we will see one problem. So what is the question? Question is first question, let f of x equals to x square plus 1, then find f dash of 2. Solution. So what is given? F of x equals to x square plus 1, and we are asked to find what is the first order derivative, f dash of 2. Actually, because we have studied this in intermediate, if x square is there, then the derivative of x square will be 2x. But as of now, we have not yet defined what is the meaning of derivative. We have not yet established the formula. What is the derivative of x power n? We have not yet established that formula. So that's why we have to use this definition. As of now, what is the meaning of derivative? The derivative is given by this one. So that's why we'll consider f dash of, because we have to find the derivative at the point 2. So f dash of 2 is given by limit h goes to 0, f of c plus h. In place of c we are having 2. So f of 2 plus h minus f of 2. This is divided by h. this is equal to limit h goes to 0, f of 2 plus h. F of x is given to be x square plus 1. F of x is given to be x square plus 1. So I have to use this definition. F of 2 plus h means 2 plus h whole square plus 1 minus f of 2. F of 2 means 2 square plus 1. So 2 square plus 1. Right? This is divided by h. Now let us simplify this. Limit h goes to 0. 2 plus h whole square. A plus b whole square. 4 plus h square plus 2h plus 1 minus 2 to the 4 plus 1, 5. This is divided by h. Further, limit h goes to 0. Here h square as it is plus 2h as it is divided by h. Remaining 4 plus 1 is 5 and here minus 5 is there. So 5 minus 5 gets cancelled, remaining is this. Further, limit h goes to 0. Here in the numerator h can be taken out. So if I take h outside, what will remain here? H plus, and here 2h is there. H is taken out means 2 will remain. So this 2 and h will get cancelled. When I take the limit h goes to 0 in this term will become 0. What is remaining? 2. Right? So this is how we evaluate the derivative of the function f at the point 2. Right? Because we don't know the formula, we have not yet established the formula for derivative of x power n. So we have to use the definition that we have seen just now. By using the definition, the derivative f dash of 2 is 2. Sorry, here the derivative okay students, I did a small mistake here. A plus b whole square formula, when you expand this, 2 square is 4, h square, then 2 to the 4h, we will get 4h here. Similarly here 4h, then here 4. Right? When I take the limit h goes to 0, what will happen? 0 plus 4. So what will remain? 4. So the derivative of f of x, that is f dash at the point 2, is given by 4. This is how we evaluate the derivative. Have a look at this, student. Okay students, we will see one more problem similar to this. That is the second problem. If f of x equals to x square plus 4x plus 3, then find f dash of 1. Right? The given function is f of x equals to x square plus 4x plus 3 and we are asked to find f dash of 1. So we'll use the definition again. By using this definition, f dash of 1 is nothing but, according to the definition, f dash of 1 is nothing but limit h goes to 0, f of c plus h, means f of 1 plus h. So f of 1 plus h minus f of c, that is f of 1 divided by h. So further, limit h goes to 0, f of 1 plus h. Use f of x is given to be x square plus 4x plus 3. So wherever x is there, we have to replace that with 1 plus h. So 1 plus h whole square plus 4 into 1 plus h plus 3. This term is over. Then minus f of 1. So 1 square, that is 1 only, plus 4 into 1 is 4 plus 3. Right? This is divided by h. Further, limit h goes to 0. Simplify this. 1 plus h square plus 2h plus 4 plus 4h plus 3 minus 4 plus 3, 7, 7 plus 1, 8. This is divided by h. Further, we have to simplify. Limit h goes to 0. H square is here. H square as it is. Then 4h plus 2h, which is 6h. And what is remaining? 4 plus 1, 5 plus 3, 8 minus 8. 4 plus 3, 7 plus 1, 8 minus 8 is 0. So remaining h in the denominator. Now further, limit h goes to 0. Now we can take h common from this. When I take h common, so what will remain here? H plus here 6, right? This is divided by h. H will get cancelled. Now you apply the limit. When you apply the limit, what will happen? This term will become 0. Remaining is 6. So the derivative f dash of 1 is given by 6. This is how we evaluate the derivative by using the basic definition. That is limit h goes to 0, f of c plus h minus f of c by h. Okay students, now we will see geometrically what is the meaning of this definition, right? That we will see now. That is the geometrical representation of derivative. That we will see now. Okay students, next topic is geometrical interpretation of derivative. Just now we have seen the definition, that is f dash of c is given by limit h goes to 0, f of c plus h minus f of c by h. This is the definition of derivative at a point c. Just now we have seen this. Now we will understand what is the meaning of that geometrically. So I am considering let f of x is differentiable. Now let us consider the graph of the function f of x. Right? This is x-axis, this is y-axis. Suppose I am having a function f of x whose graph is something like this. So this is the graph of function f of x. Right? Students, let this is the point C. Then corresponding to this point, here one point will be there. That point is given by some p, which is c comma f of c. Right? Suppose students, one more point is there, which is at a distance of h from c. C is here, then here this point will be c plus h. This point is at a distance of h from c, that is c plus h. Then corresponding to this, on the graph there will be a point. Consider this point as q. Then this point will be c plus h comma f of c plus h, right? Then this point, let this point be n. Then this distance is given by h, right? This distance is given by h, and the tangent at this point is given by like this. So this is the tangent. This is the tangent to which f of x, at which point? At c. Tangent to f of x at c, right? Further I'm connecting these 2 points, p and q. Then I'll get a line like this, right? So initially what was there? Only the graph of the function f of x was there. I considered a point c on the line x. Then corresponding to this point, there will be a point p on the graph of the function f of x, which is given by p of c comma f of c. Further, I am considering one more point, which is c plus h, which is at a distance of c from, which is at a distance of h from c, right? C plus h. Then corresponding to this point, there will be a point on the graph of function f of x, which is given by q, which is c plus h and f of c plus h. I am considering this point, I am connecting this and considering this point to be n. I am considering the tangent here at the point p, which is the tangent to f of x at c, and also I am joining these 2 points p and q, right? I am joining these 2 points p and q. Then I am considering now slope of chord. This line is called as chord. Slope of chord PQ is given by, how do we find, suppose this is the triangle, then how do we find the slope of this? Slope of this line is given by tan of QPN, angle QPN. This is from the geometry. I am writing slope of chord PQ is given by tan of angle PQN. Then if you consider this, it is a triangle. It is a triangle and the angle is here, QPN. Then tan of QPN is nothing but opposite side by adjacent side, that is QN by PN. So this is nothing but Qn by Pn, right? What is Qn? Qn is this distance. This distance is given by upper point minus lower point. So how do we get this distance? We get by this point minus this point. We have to subtract the y coordinates, that is f of c plus h minus f of c. This distance we will get f of c plus h minus f of c, right? This is divided by, then Pn. Pn is Pn means this distance. This distance is given by h, right? So we got slope of chord PQ to be f of c plus h minus f of c by h. Further, you leave this. Further, I am considering as q goes to p. As q goes to p, when this point q reaches to, on this curve, when this point q reaches to p, then what will happen? When this point q reaches to p, then this distance will reduce. Then this distance will reduce. That is, h will become 0. As q goes to p, this implies h goes to 0. Therefore, you consider this. Limit q goes to p. What is here? Slope of chord PQ. Slope of chord PQ, right? Which is equal to, now here h goes to 0. As q goes to p, h goes to 0. Therefore, limit h goes to 0. Limit h goes to 0. What is remaining? F of c plus h. F of c plus h minus f of c by h, right? As q goes to p, what will happen? As the point q goes to p, then what will happen? This line will be when this q is here, then the line will be something like this. When q is here, then the line will be something like this. When q is here, like this. So gradually, when q reaches to p, gradually this chord PQ will become the tangent, right? So this chord PQ will become the tangent. Then here, when q reaches to p, slope of, instead of chord PQ, it will become slope of tangent at the point C, right? This is equal to, limit h goes to 0, f of c plus h minus f of c by h is nothing but, according to this, according to the definition, previously we have seen, according to this, it is nothing but f dash of c, right? So what we can say geometrically is, the derivative of the function f, at the point c is nothing but, the derivative of the function f at the point c is nothing but slope of the tangent drawn at the point c, right? Geometrically, what is the meaning of derivative? The derivative is nothing but, suppose this is the graph given to me, this is the function given to me, then the derivative of this function at this point c is nothing but the slope of tangent, drawn at the point c. At this point c, corresponding to c, on the graph of the function, I am drawing a tangent. The slope of that tangent is nothing but the derivative of the function at that point c. Geometrically, the meaning of derivative is the slope of tangent at the corresponding point where you are finding the derivative, right? So this is the geometrical meaning of derivative. So try to understand this, students. Okay, students, just now we have seen what is the geometrical interpretation of the derivative of a function. So the geometrical interpretation says that the derivative is nothing but, derivative at a point x equals to c of a function is nothing but the slope of the tangent. So what is the meaning? Suppose I am having the graph, then suppose if I want to find, suppose this is the graph of the function f of x, then if at this point if I want to find the derivative, then the derivative is nothing but slope of the tangent drawn at this point, right? Slope of the tangent drawn at this point will give you the derivative of that function, right? Okay, students, next topic is derivative of a function. Now I am going to define. Previously we have seen derivative of a function at a point. Previously we have seen derivative of a function at a point. Now we will see the derivative of a function. I am not specifying where it is. I am not specifying where it is. Directly I am defining the derivative of a function. Right? Suppose students, I am having a point I am having a function f of x which is defined on an open interval a comma b. Right? F of x is a function which is defined on the open interval a comma b. Let the point C belongs to the open interval a comma b. Then suppose at this point, what will be the derivative? Just now according to the definition we have seen, at this point the derivative f dash of c is nothing but limit h goes to 0 f of c plus h minus f of c by h, right? This is nothing but the derivative of f at this point. Now if I find the derivative at all the points, if I find the derivative of this function f of x at all the points, then I'll get this kind of limit at all the points. Then that will give me a new function. That function is actually called as derivative of a function. How do we define? Suppose I am having a function f of x which is defined on the open interval a comma b, and let c be any point in the open interval a comma b, then the derivative of function f at the point c is given by f dash of c equals to limit h goes to 0 f of c plus h minus f of c by h. This is the definition of derivative at any point c. Now instead of at any point, at all the points if I find the derivative, at all the points in between a and b, if I find the derivative, then I'll get this kind of limit values at all the points. Right? That will give me a new function. That function is called as derivative of a function. That function is defined by, so derivative of f of x. I am not specifying at which point. Generally I am writing, in general I am writing derivative of f of x is, how do we write? F dash of x. It can be any point, at all the points. F dash of x is given by limit h goes to 0 f of x plus h minus f of x is divided by h. So this is the definition of derivative for the function f of x. What we are doing, we are replacing c with x. Then we will get f dash of x limit h goes to 0 f of x plus h minus f of x by h. So this is the definition of derivative of a function at any point, right? Okay, I'll make a note here. This note says that finding the derivative of any given function. Suppose I am given a function f of x equals to, suppose I am given a function f of x equals to some 2x, or f of x equals to some 6x square, or f of x equals to some 1 plus x cube, then, and I am asked to find what is the f dash of x, what is the derivative. I am not specifying the point. I am not specifying the point. Directly I am writing f dash of x. Similarly, if I write f dash of x here, similarly, what is f dash of x? What are the values of this f dash of x for all these functions? Now how to find that? Right now we have not established any formula. We cannot use the formula here. So what will be the derivative of 2x? By using the formula we know that derivative of 2x is 2. And by using the formula we know that derivative of 6x square is nothing but 12x. And here 3x square. We know that. But we till now we have not established any formula. So how to find the derivative of that? By using this f dash of x equals to limit h goes to 0 f of x plus h minus f of x by h. By using this definition we have to evaluate these derivatives because we have not yet established formula. By using this definition only we are going to establish the formula. So finding the derivative of any given function by using this definition is called as first principle of derivative. That is what we call first principle of differentiation. Right? What it is? First principle of differentiation is nothing but finding the derivative of any such function by using this definition. That is limit h goes to 0 f of x plus h minus f of x by h. By using this definition, if we find the derivative of any function, then such process is called as first principle of differentiation. Right? Now we will see few problems. We'll use this, means by using first principle how to evaluate the derivatives, that we will see now. So problems. First problem, let f of x equals to x. Very simple function we are considering, f of x equals to x. Then show that what will be the derivative of this? Already we have studied in intermediate, so that's why we can say that the derivative of x is 1. Then show that f dash of x is 1, right? Very simple problem we are considering to understand how we are going to use this definition, because we don't know what is the derivative of x. So that's why we have to use this formula, f dash of x. What we are asked to find? F dash of x, and we are asked to show that f dash of x is nothing but 1. We are given f of x equals to x. So solution. So what is f dash of x? F dash of x is nothing but limit h goes to 0, f of x plus h minus f of x by h. We have to use this definition. So what is there? F of x is already there, given f of x equals to x. And what is f of x plus h? F of x plus h is nothing but wherever x is there, that I have to replace with x plus h. Here x is there, so x plus h. Now what is f dash of x? F dash of x is equals to, I have to use this, f dash of x is equals to limit h goes to 0, f of x plus h minus f of x by h, right? Limit h goes to 0, f of x plus h. Just now I have computed here, f of x plus h is nothing but x plus h minus f of x. F of x is already x, this is divided by h. Now further, limit h goes to 0, this x and minus x will get cancelled, so h by h and h will get cancelled. We don't need to apply limit because there is no h here, h got cancelled. So h get cancelled means what will be remaining? Only 1, right? So that is why f dash of x, when f of x is given to be x, then f dash of x will be 1. So what we have done here, we are asked to find f dash of x. We are asked to show that f dash of x is 1. So what is f of x? F of x is given to be x. Then what is f of x plus h? We have to evaluate this by replacing x with x plus h. Therefore x is replaced with x plus h. Then the definition, f dash of x, by using this definition, f dash of x is nothing but limit h goes to 0, f of x plus h minus f of x by h. Limit h goes to 0 as it is, f of x plus h is nothing but x plus h minus f of x is nothing but x divided by h. So x will get cancelled, h and h will be remaining, again h and h will get cancelled, so 1 will be remaining. That is why f dash of x, when f of x equals to x, f dash of x is 1, right? We'll see next problem. We'll see the second problem. Let f of x equals to k, then f dash of x is 0. What is given? F dash of x equals to k, that is a constant. F dash of x equals to k is a constant, then we have to show that the derivative of that constant is 0. Again, so given f dash of x equals to k, then this implies f of x plus h. Wherever x is there, we have to put x plus h. Here k is there, there is no x here. If x is there, then we have to write x plus h, other terms as it is. But here there is no x, so k as it is, right? Then f dash of x, is given by limit h goes to 0. What is the formula? F of x plus h minus f of x by h. Okay, this kind of derivative or differentiation is called as first principle. The differentiation by using first principle, because I am using this formula, right? Limit h goes to 0, f of x plus h is given by k minus f of x is given by k. is divided by h. So k gets cancelled, what will remain? 0. So that's why when f of x equals to any constant, then the derivative will be 0. So what we can say, derivative of a constant is always 0, right? Have a look at this, students. Okay students, next we are having two more problems. Previously we have seen if f of x equals to x, then f dash of x equals to 1. Then we have seen if f of x equals to k, then f dash of x equals to 0. That was the second problem. Now third problem is if f of x equals to root x, where x is greater than 0, then we have to show that f dash of x is 1 by 2 root x. So what is given? Given f of x equals to root x, then what will be f of x plus h? F of x plus h will be root x plus h, right? If f of x equals to root x, then f of x plus h will be, wherever x is there, we have to replace that with x plus h. Now, what is the formula? F dash of x is equal to limit h goes to 0, f of x plus h minus f of x. This is I am writing from the first principle. Limit h goes to 0, f of x plus h minus f of x by h. This is equal to limit h goes to 0. F of x plus h is given by root x plus h minus f of x is root x is divided by h, right? So if you apply the limit, you will get 0 by 0, because here when you take limit h goes to 0, here 0. When you take here 0, root x minus root x will be 0. So 0 by 0, that is indeterminate form we will get. So whenever we are getting 0 by 0 or infinity by infinity, in the previous session we have seen that whenever we are getting 0 by 0 or infinity by infinity, when we substitute the value of the limit, then what we have to do, either we have to do the rationalization or we have to apply the L'Hospital's rule. Here we can do rationalization because it involves square roots. So I am rationalizing it. What we have to do, square root of x plus h, this minus we have to write it as plus root x divided by root x plus h plus root x. So this is how I am rationalizing. Then further, limit h goes to 0, what will happen? A minus b into a plus b is a square minus b square, that is x plus h minus x is divided by h into square root of x plus h plus root x, right? Here what will happen? This plus x, this minus x will get cancelled. What is remaining here? H and here h. This h and this h will get cancelled. Now we can apply the limit. When we apply the limit, what will happen? You apply the limit. Wherever h is there, you put 0. In the numerator 1 will remain because this h got cancelled. So 1 will be remaining divided by here square root of x plus 0, x plus 0 plus root x, which is nothing but 1 by root x plus root x is nothing but 2 root x. Therefore f dash of x, when f of x is given to be root x, then f dash of x will be 1 by 2 root x. This is how we use first principle to find the derivative of root x, and we got the derivative to be 1 by 2 root x, right? We'll go for the next problem. So what is the next question? Fourth one, let f of x equals to e power x. Let f of x equals to e power x. Then we have to show that f dash of x is again e power x. That is the derivative of the function e power x is nothing but e power x. That we know. But how we are getting that we are establishing now. By using the first principle, we are trying to establish the derivatives of few basic functions, like what is the derivative of x, what is the derivative of constant, what is the derivative of root x, and what is the derivative of e power x, what is the derivative of sin x. That we are establishing by using this formula called first principle, differentiation by first principle. By using this formula, we are finding or we are establishing few general formulae, right? Here f of x, what is given? F of x equals to e power x is given. Then this implies what is f of x plus h? This will be e power, wherever x is there, that should be replaced with x plus h. Here x is there, that should be replaced with x plus h, right? Now, what is the formula? F dash of x is given by limit h goes to 0, f of x plus h minus f of x by h. This is equal to limit h goes to 0. What is f of x plus h? F of x plus h is given by e power x plus h minus f of x. F of x is given by e power x. This is divided by h. This is equal to limit h goes to 0. This e power x plus h can be written as, if e power a plus b is there, that can be written as e power a into e power b. Similarly here, e power x into e power h minus e power x divided by h. Further, limit h goes to 0, e power x can be taken out, because e power x is not at all depending on the limit, that can be taken out of the limit, right? I am taking e power x from this one and this term outside. Because e power x is not at all depending on h, we don't need to apply this limit on e power x. So that's why I am writing e power x outside of the limit. Then what will remain here? E power x is taken out, e power h will remain, minus e power x is taken out, 1 will remain, divided by h. And we know from a standard formula that you have studied in your intermediate, from that, what is the value of limit h goes to 0? E power h minus 1 by h. E power theta, limit theta goes to 0, limit theta goes to 0, e power theta minus 1 by theta. The value of limit theta goes to 0, e power theta minus 1 by theta is given by 1. That you have studied in your intermediate. So apply that here. E power x into the value of this limit is 1. So that's why what will remain? E power x. So when f of x is given to be e power x, then derivative of that, that is f dash of x, will be e power ax. Similarly, if f of x equals to e power ax is given, so we can also prove, if f of x equal to e power ax is given, then by using this formula only, we can establish that f dash of x is given by a into e power ax. This we can establish by using this formula, that is called differentiation by using first principle, right? So how many formulas we have established till now? We have established f of x, if derivative of x is 1. Also we have established derivative of constant is 0. Then derivative of root x is 1 by 2 root x, and derivative of e power x is e power x. Next we will see derivative of sin x. What will be the derivative of sin x? How to establish that derivative? We know that derivative of sin x is cos x, but how we are getting that? That we are establishing now, right? Have a look at this. Okay students, now we will see one more problem, that is the derivative of sin x. Then we will note down few formulae which are standard, right? And those formulae can be proved by using this differentiation by first principle. So first we will see the problem, then we will go for formulae. So this is the fifth problem. Let f of x equals to sin x, right? Then f dash of x is given by cos x. This we have to prove, right? What is given? F of x equals to sin x, and we are asked, we have to prove that f dash of x equals to cos x. So given f of x equals to sin x, then this implies f dash of x equals to, f of x plus h is equal to sin, wherever x is there I have to write x plus h. Here x is there, so x plus h. Now we know the formula, f dash of x, this is from first principle, f dash of x equals to limit h goes to 0, f of x plus h minus f of x is divided by h, right? So this is equal to limit h goes to 0, f of x plus h. F of x plus h is nothing but sine x plus h minus f of x. F of x is nothing but sine x is divided by h. Students, look at this carefully. It is in the form of sine c minus sine d. So we know the formula, sine c minus sine d, which is given by 2 sine c minus d by 2 cos c plus d by 2. This formula we are going to use. Sine c minus sine d is nothing but 2 sine of c minus d by 2 into cos of c plus d by 2. That formula I am going to use. Limit h goes to 0. So in place of c I am having x plus h, and in place of d I am having x. So 2 sine c minus d by 2. So c minus d, that is x plus h minus x by 2 into cos c plus d by 2, x plus h plus x by 2. This whole thing is divided by h, right? So students, what I am going to do is I will multiply with 2 here and divide this with 2, right? And I will cancel out this 2 and this 2. So what will remain here? Limit h goes to 0. Here x and x will get cancelled. Only h by 2 will remain. So limit sine of here h by 2. This is divided with h by 2. Actually I am separating the limit. I am putting the limit for first term and limit h goes to 0 for the second term, that is cos term, which is nothing but cos of, see, x plus x is nothing but 2x. 2x divided by 2 is nothing but x plus h by 2 as it is, right? Already we know that limit h goes to 0, sine h by limit theta goes to 0, sine theta by theta. The value of this limit will be 1. Limit theta goes to 0, sine theta by theta. The value of that limit will be 1. We have studied this in intermediate limit, right? Same thing here. Limit h goes to 0, sine h by 2 by sine h by 2 is nothing but, if you want you can write here h by 2 also. When h goes to 0, h by 2 will always goes to 0. So that's why sine theta goes to 0, sine theta, limit h theta goes to 0, sine theta by theta value is 1. So what will remain here? Limit h goes to 0, here 1 will remain, and here limit h goes to 0, cos x plus h by 2 is nothing but cos x, right? So the value will be cos x. F dash of x value will be cos x. So this is how we have established that derivative of sin x is cos x. Okay students, so these all the formulae that we have seen in intermediate that can be established by using this first principle. Now we will note down few formulae which we will be using very frequently. So all those formulae can be established by using this first principle. We will note down few formulae here. So we will make a note. In this we will note down those formulae. So first formula is, and all these formulae that I am going to write now can be proved or can be established by using this differentiation by using first principle, right? So first formula, d by dx of x power n. We can find that the value of this is n into x power n minus 1. Second formula, d by dx of constant k is 0. Third formula, derivative of e power x is e power x only. We have proved this. Also, if I find derivative of e power ax, then it is a into e power ax, right? Then fourth one, d by dx of log x is 1 by x. Also, if I find d by dx of a power x, then it is a power x log a. So these are the few basic formulae that we can prove. Already we have proved, instead of x power n we have considered x power 1. we have proved that derivative of this is 1, and derivative of k also we have proved, derivative of e power x also we have proved. Similarly, we can prove derivative of log x is 1 by x and a power x is a power x into log a. Also, few more formulae we will see. Sixth formula, that is d by dx of sin x. This we have proved just now. Derivative of sin x is cos x, right? The next one, d by dx of cos x is minus sin x. We can prove this also, right? Same way, derivative of tan x is nothing but secant square x. Then next, derivative of cot x. Derivative of cot x is nothing but minus cosec square x, right? Next, derivative of sec x, secant x is nothing but secant x tan x. Next, d by dx of cosecant x is nothing but minus cosec x cot x, right? So these are the few basic formulae that we will be using very frequently. You people have to memorize these formulae, right? Always you have to remember these formulae throughout your engineering mathematics, right? In semester 1 we will be using this formulae in mathematics 1, in semester 2 we will be using in mathematics 2, and semester 3 also we will be using, not only in mathematics but also in other subjects related to electrical, EC, in all those subjects, in civil, mechanical also we will be using this formulae, derivative formulae. Always you have to remember this formulae, you have to memorize this, right? And these formulae are, we are not writing, these formulae are not falling from the sky. These formulae are well established. Just now we have established that f of x is sin x, then f dash of x is cos x. That we have established by using first principle. In the same way, we can establish that derivative of cos x is minus sin x, derivative of tan x is secant square x, and so on, right? All these formulae are well established and you have to memorize this. Have a look at this. Okay students, just now we have seen few standard formulae. By using those standard formulae, we will see few problems, right? So the problem is, find the derivatives of following. One function will be given, we have to evaluate the derivative of that. So first function is ax square plus b by x, right? Where a comma b are constants. What is the question? We have to find the derivative of following, means this one, ax square plus b by x, where a and b are constants. X is only the variable, means we have to differentiate the variables, we have to keep the constants as it is, right? Okay students, what we have to do, we have to find d by dx of ax square plus b by x, which is equal to, a is a constant that should be kept as it is, then d by dx of x square plus b as it is, then d by dx of 1 by x, right? A into derivative of x square is nothing but derivative of x power n is nothing but derivative of x power n is nothing but n into x power n minus 1. So we have to use that formula. N into means 2 into x power n minus 1, that is 2 minus 1, right? Plus b into this 1 by x can be written as d by dx of 1 by x can be written as x power minus 1. What will happen here? 2a into x power 2 minus 1 is nothing but x, plus b into again x power n formula, derivative of x power n is nothing but n into x power n minus 1, right? So 2ax plus or minus, because minus we are getting, b by x power minus 2 can be written as x power minus 2 you take in the denominator, that will become x power plus 2. So b by x square So derivative of ax square plus b by x is nothing but 2ax minus b by x square. This is how we evaluate the derivative for any given functions, right? In the same way, we'll consider one more problem. Right, square root of ax plus b. What is given? Square root of ax plus b is given. We have to find the derivative of this. So solution, d by dx of square root of ax plus b. Right, it is in the form of root x. Derivative of root x is nothing but 1 by 2 root x. Derivative of root x is nothing but 1 by 2 root x. So what we will get? 1 by 2 root ax plus b. If x is there, then 1 by 2 root x. But here instead of x, what we are having? We are having ax plus b, where obviously a and b are constants. So derivative of root d by dx of square root of ax plus b is nothing but 1 by 2 root of ax plus b. Again, the derivative of ax plus b, right? So this is equal to 1 by 2 into square root of ax plus b into a as it is, derivative of x is 1 plus derivative of b is 0. So what will remain here? A by 2 into square root of ax plus b. This is the derivative of square root of ax plus b. What is the derivative of square root of ax plus b? A by 2 root ax plus b, right? So this is how where we are using the standard formula. In this problem we have used the standard formula here, derivative of x power n. Here also we have used derivative of x power n. Here we have used derivative of root x. First we have used derivative of root x, then derivative of x power n here, right? This is how we use the standard formula for derivative to find the derivative of any given function, right? Have a look at this. Okay students, we are having two more problems. We have to find the derivative of sine x square plus 1. We have to find the derivative of root x. So first we will find the derivative of sine x square plus 1. Already we have seen what is the derivative of, in its standard formula we have seen the derivative of sine x is given by cos x. So cos, in place of x we are having x square plus 1, right? D by dx of sine of something is nothing but cos of something, again the derivative of that something, that is d by dx of x square plus 1, right? This is equal to cos x square plus 1 into d by dx of x square plus 1, derivative of x square. Derivative of x square is nothing but 2 into x power 2 minus 1 plus derivative of 1 is a constant here, derivative of 1 is 0, right? So what we'll get here? X power 2 minus 1 is nothing but 1. So 2x into cos of x square plus 1, right? This is how we find the derivative of sine of x square plus 1. What we have done first we have evaluated the derivative of sine, that is cos, sine of something, cos of something as it is, then the derivative of that something, x square plus 1, derivative of x square plus 1 is 2 into x power 2 minus 1 plus 0. So 2x into cos of x square plus 1, right? This is how we find the derivative. The next problem is we have to find the derivative of root sine x. So d by dx of root sine x. Already from the standard formula we know that d by dx of root x is 1 by 2 root x, but in place of x we are having sine x. So 1 by 2 root sine x, 1 by 2 root sine x. Then again derivative of sine x, root something is 1 by 2 root something, again the derivative of that something, right? 1 by 2 root sine x, and the derivative of sine x already we know, this is cos x. Therefore the final answer will be cos x by 2 root sine x, right? This is how we find the derivative by using the standard formula. Okay students, we'll end today's session here and we'll meet in the next session. with the new topics like how to find the derivative when two functions are multiplied, or how to find the derivative when two functions are given in the numerator and denominator form, that is fraction form. Those rules are called as derivative of product and derivative of quotient, right? That we'll see in the next class. See you in the next class, students.